Segment 2. Why must the oil be purified?
We can next examine why lube oil has to be purified. Lube oil has to be purified, first of all, in order to remove particulate matter. That can be done with filtration. We also have to purify the lube oil in efforts to remove water. Water, as we will see in a few minutes, can be extremely detrimental. We want to purify the lube oil in an effort to restore the flash point and the viscosity. And we do this sometimes by only removing the water constituents, but in many instances there is air contamination or perhaps gas contamination. In some instances on certain machines we have contamination coming from process gases, which may in fact then lower the flash point. So we have to remove in those instances light hydrocarbons. Also, to ensure the component life of machines which have certain types of gases contaminating the lube oil, we have to be sure that we remove H2S, because babbited bearings can be seriously deteriorated by H2S contamination. This, incidentally, is a very common problem in lube and seal oil systems that we have on major process gas machines. When you study the allowable water contamination, it is quite clear that it is a function of the oil temperature and the relative humidity. Why is that? Well, it's simply because we have to make a distinction between free water and dissolved water. A certain amount of lube oil will completely absorb a certain amount of water, and if the amount of water exceeds the saturation limit, free water is going to form. So again, we have to contend with two types of water: water in its free form after saturation has been reached, and water which dissolves completely in the oil until we reach the saturation limit. Each method of water removal has to be looked at in its own context. We have, for instance, for the removal of free water, such methods as coalescing, centrifuging, and also vacuum dehydration. These are cost-effective in various types of applications, and each of these methods, of course, can be made reliable by proper engineering. Free water is the more detrimental of the two. You recall we briefly mentioned that there is free water and dissolved water, so the removal of free water is most important. Free water, if you allow it to exist in a lube oil reservoir or in a circulating system, will remove the rust inhibitors, promote the formation of sludge. Sludge, incidentally, is formed if you allow trace amounts of water to come in contact with trace amounts of rust, flakes of oxidation that come off the lube oil lines or any other components of the machine. Free water then is responsible for degradation of components. It's responsible for relay valves and pistons that are sticking in hydraulic units or in the valve gear of major steam turbines. Again, in major steam turbines, free water can be held accountable in many instances for the seizing of trip bolts. Also, journal bearings have frequently corroded. Contrary to normal assumptions, babbited bearings can indeed corrode rather severely if they are exposed to certain degrees of water contamination for long times. And then another one that we may keep in mind, eddy current probes, which are part of modern vibration monitoring systems, will frequently deteriorate if they are exposed to free water. Here's a saturation line, and we can see that on the horizontal scale we see water concentration. On the vertical scale we see the various temperatures of the lube oil, and the saturation line moves as a function of water concentration, temperature, and of course also the properties of the lube oil that we are dealing with. Here we see how anti-friction bearing life can be very seriously impaired by excessive amounts of water. In this particular test, we see that for a water concentration of 100 parts per million, the relative life of the anti-friction bearing is 1 times X years. And if we increase the water concentration to 400 parts per million, the life will have dropped to 40% of what it would have been with the concentration of 100 parts per million. We can conclude here that for the removal of free water, it is feasible to use centrifuges or coalescers, but it is important for us to realize if these centrifuges or coalescers are used, they must be operated continuously, since they only remove free water. This means at the very best you are at the saturation point. The moment you bring in any kind of additional water, you have exceeded saturation. You're dealing with free water, must be continuously removed. Vacuum dehydrators, on the other hand, allow intermittent operation of the purifier because they are the only machine, the only unit which gets us into the dissolved area. Now, in summary, if we could find methods of effectively removing contaminants, not only the solid particles, but also water and perhaps light hydrocarbons, which contaminate certain lube valve systems, we can, as a result of it, gain considerable amounts of money. We have reduced maintenance, we have increased reliability of the machinery.